This presentation introduces the concept of statistical power. What is power? Power is the probability of rejecting a null hypothesis when it is false. Or, from the opposite side of the coin, power is the probability of detecting an effect that is a difference or an association when it is present. To more fully understand this concept, we'll discuss alternative and null hypotheses. The alternative hypothesis typically reflects the expectation of the researcher. What type of difference or association do they think will exist? The null hypothesis encompasses all other possible outcomes. Thus, the two hypotheses should be inclusive of all possible outcomes from a text, and the two hypotheses should be mutually exclusive, meaning they can't both be true at the same time. These terms are often easier understood with a concrete example. If a researcher thinks men are taller than women, the alternative hypothesis is that the height of men is greater than the height of women. Then we can consider the other possible outcomes. If men are not taller than women, they could be shorter than women or equally tall. Thus, the null hypothesis is that the height of men is less than or equal to the height of women. These two statements then include all possible outcomes, less than, greater than, or equal to, and they do not overlap. If men are taller, they can't possibly be shorter or equal in height to women. And if men are shorter or equal in height to women, they can't possibly be taller. Once the hypotheses are stated and data collected, they can be tested. Specifically, we test to see if the null hypothesis is false. That is to say, do we find an effect, a difference, or an association to exist? If we find an effect, we reject the null hypothesis. If we reject the null hypothesis, there are two potential outcomes. One, we erroneously reject the null hypothesis when it is true in the real world. Or two, we correctly reject the null hypothesis and it is false. In essence, the experiment provides a view of the world, but occasionally the experiment is not consistent with the real world. If the conclusion from the experiment is incorrect, we have rejected the null hypothesis in error. Similarly, if we fail to reject the null hypothesis, there are two potential outcomes. We correctly fail to reject the null hypothesis when it is true, or we erroneously fail to reject the null hypothesis and it is really false. Unfortunately, without collecting additional data, we do not know which outcome has truly occurred because the data used for the analysis is the information we have about the real world. We can connect these ideas back to the hypotheses about height and gender. The alternative hypothesis is that men are taller than women, and the null hypothesis is that men are shorter or equal in height. If we find men are taller than women, we reject the null hypothesis because it appears men are taller. However, it is always possible this decision is incorrect, and really, women are taller or there is no difference in height between the genders. Based on the amount of data available from hundreds of studies, we have enough information to know that men, on average, are in fact taller in the real world. Consequently, we probably do not have an error if this is what we find, but in most research, we cannot be so certain of what's happening in the real world. In contrast, if we find men are shorter or equal in height compared to women, we fail to reject the null hypothesis. And again, based on the amount of data available, we know this decision would be an error. Still, it is possible that this outcome could occur. For example, if we evaluated height for an hour and the women's basketball team happened to walk by during that hour, the team could skew our data and lead to the incorrect result. Hopefully we would notice the outliers, but these types of events can occur without researchers being aware. The probability that we correctly reject the null hypothesis when it is false in the real world is known as power. So, returning to our original question, what is power? We now know that power is our ability or the probability of rejecting a null hypothesis when it is false. Similarly, it is our ability to detect an effect, some difference or association, when it is present. In this case, it would be our ability to find that there's a difference between men and women, assuming one exists in the real world. Power is influenced by four main things. The first is effect size, the second, unexplained variability, the third, sample size, and the fourth, significance level. Effect size is based on the size of the difference or association. As the difference between groups is larger, or two variables are more highly associated with each other, the effect size is larger, and we will subsequently have more power. Unexplained variability also influences power. If scores on a variable are influenced by other factors not included in our study, or the data are collected in a way that inflates error, or our measure is not reliable, power will be negatively impacted. It will be lower. There are occasions when we are interested in research questions about small differences or associations, though, or there's unexplained variability that we can't control for. Sample size can help with those situations because as sample size increases, power also increases. And so we can collect more data from more participants in order to increase power in those circumstances. Finally, significance level influences power. The significance level reflects the researcher's comfort with making a mistake or an error in their decision. If we're the researchers and we are relatively comfortable with a possible error, we can increase our significance level. Thus, the likelihood of an error is increased. At the same time, power is increased because we require a smaller effect in order to reject the null hypothesis. Returning to our example, when we consider the difference in height between men and women, the effect size is the difference between men and women on height. If that difference is relatively large, we will have more power. Conversely, if the difference is relatively small, we will have less power. In this research situation, unexplained variability is any difference in height among the women and differences in height among the men. These differences are not explained by gender because they represent the difference in heights that occurs due to genetics, childhood diet, and similar factors other than gender. As the difference within the genders is greater, so as we see that one man is really tall and one man is really short, we will tend to have less power. Sample size focuses on the number of men and women that we measure. If we measure the heights of more people, we will have more power. Conversely, if we measure the height of fewer people, we will tend to have less power. The final factor influencing power is significance level. This factor is determined by the researcher. If we want to be sure there is a difference between men and women's heights, we can set the significance level relatively low. If we are more comfortable with saying there is a difference when there is not a real difference in height, we could increase the significance level to 5%, for instance, which increases power. In conclusion, power is the probability of detecting a difference or association when it exists in the real world. This ability to detect an effect, if it exists in the real world, is influenced by four main factors: the effect size, the unexplained variability, the sample size, and the desired significance level.